Hello everyone, and in this video we're definitely looking at more of an A-level kind of application of quadratics, and this is modeling with quadratics. So we're going to be looking at question 8. So in question 8, modeling with quadratics now, and again this could be, they love this kind of thing in the exam. Modeling with quadratics is quite frequently coming up in A-level papers. Andrew and Bob are playing with a bouncy ball. Andrew launches the ball at time t equals 0. The height of the ball above the ground in meters, t seconds after the launch, can be modeled by the function as given there. Bob catches the ball 0.9 seconds after it was launched. In this question, we're only considering the vertical displacement. Horizontal displacement can be ignored. So it's, in other words, we're just imagining the whole thing's taking place in one flat plane. From what height did Andrew launch the ball? Okay, so this is question 8. First of all, let's have a look at the function. h of t, our quadratic, is 6t squared minus 6t plus 1.5. Okay, now the ball was launched at time t is equal to 0. So in other words, it's h of 0, which is going to be basically 6 times by nothing squared minus 6 times by nothing plus 1.5. So h at 0 is equal to 1.5 meters. So the answer is the ball was launched from a height of 1.5 meters. Part B. At what time did the ball hit the ground? Now, the ball hit the ground because the function is the height of the ball above the ground. So when the ball has hit the ground, this is 0. So the ball hits the ground, its height above the ground is 0. In other words, we basically just got to solve this quadratic now in order to work out what the height of the ball above the ground is. So we're going to put that into the quadratic formula. So we're just going to have t is equal to minus. I'm just subbing into the quadratic formula here. You can just solve it on your calculator, but to make sure that you get method marks, it's good to show working. So I'm just subbing into the quadratic formula. Okay, like so. And that's going to give me, when I work that out, 6 plus or minus root 36 minus 36 over 12. So t is equal to 6 over 12, which is equal to a half. So 0.5 seconds is our answer to part B. Okay, and again, all I've done there is just solve the equation for 0. Okay, so what time did the ball hit the ground? The ball hit the ground at 0.5 seconds. Part C, now this is something keying into our earlier lessons on completing the square. It says rearrange h of t into this format. Now they're particularly fond of this at A-level. I have seen them start to introduce this at GCSE as well. Just recently, in the 1 or 2 papers, they've been changing the way that the completing the square formula is represented, and that's what's happening here. So when you first see that, you might not recognize that as being completing the square form, but it is, because if you were to rewrite this, just change the order in which it's written, then you would have that. And that's more like the format that you might be more familiar with. So if it was written like that, you can see how that directly compares with completing the square format. But I think one of the first obstacles is when students see this, lots of students don't immediately recognize that as completing the square. So my advice would be on this one, just complete the square in completely the normal fashion, and then just rearrange the order in which it's written in the end. So for part C, we're going to just complete the square on the quadratic, as we have discussed in previous videos. Okay, so I'm going to take out a factor of 6 here to start off with. 6 open bracket t squared minus t square bracket plus 1.5. I'm now going to complete the square as before on the bit in the square bracket. So it's going to go to minus a half squared minus a half squared. plus 1.5. Okay, and then now I'm going to work out what that is. So t minus a half all squared minus a quarter plus 1.5. And then I'm going to now expand my brackets. So 6 t minus a half squared minus 6/4 plus 1.5. And when I combine those two together, let's see what we get. Well, 6/4 is 3/2, and 3/2 is the same as 1.5. So when I combine these two, they cancel. So I'm just left with 6, open bracket, t minus a half all squared. Now, at first, that might not seem to be in the required form, but it is in the required form because we just got to think about the fact that in this case, the q is essentially 0. Okay, so if we were going to write that in the form, the required form, q add r, open brackets, t add p all squared, we could technically write it as 0 plus 6, open brackets, t minus a half, close brackets, squared. Okay, so that is written in the required form, and that is part C done. State the values of the constants P, Q, and R. Okay, so P is 0. Sorry, Q is 0. R is 6. That's our R. And our P is minus a half. Okay, that's fine. So that's how we do that bit. Now, it says part D of this question, it says, at what height did Bob catch the ball? Okay, now Bob caught the ball 0.9 seconds after it was launched. So we've just got to work out what is h of 0.9. So Bob caught it 0.9 seconds. So that is going to be 6 times by 0.9 squared minus 6 times by 0.9 plus 1.5. And when we work that out, that turns out to be 0.96 meters. So Bob caught the ball when it was 0.96 meters. Now, for the final part of this question, this modeling with quadratics, it says, if Bob had not caught the ball, when would it have reached 1 meter high for the second time? So we've got a quadratic here with a negative coefficient in front of the... Oh, no, it's not actually a negative coefficient. Okay, that's fine. So let's have a look and just see when would Bob have caught it the second time when it reached a height of 1 meter. Okay, now in order for that to be the case, what we need to do is set the height equal to 1. And basically we're going to set the height equal to 1, and we're going to solve it to find out what the 2 times are when the ball is at 1 meter. So we've got 6t squared, and it's plus 6, minus 6t rather. Minus 6t there, minus 6t. And we have plus 0.5, plus 1.5 rather, plus 1.5. There we go. And that is what we are going to be solving. Okay, so let's solve that now. That's going to give us that 1 is equal to, we're going to take that thing over the other side. That's going to give us 6t squared minus 6t plus 0.5 equals 0. And we're now going to solve that. Okay, so let's solve that by putting that into the quadratic formula. And we put that into the quadratic formula, that is going to be t is equal to minus 6 plus or minus the square root of minus 6 all squared minus 4 times by 6 times by 0.5. All of that over 2 times 6. And when we solve that, that's going to go to 6 plus or minus root 24 all over 12. So t is going to equal 3 plus or minus root 6 over 6. And that's because root 24 can be thought of as 2 root 6. And then we've basically thought of root 24 as 2 root 6 and divided everything by a common factor of 2. So these are our 2 values when the ball is exactly 1 meter. it's at exactly 1 meter when we've got t is 3 minus √6/6, and it's at 1 meter again when the time is 3 plus √6/6. And the question's asking us what's the when would it have reached a height of 1 meter for the second time? And this time is bigger than this time, so it would have reached a height of 1 meter at this second time, which is that value there. And that's an example of a modeling with quadratics question, very popular one on A-level exam papers. I hope you found that useful, and I'll see you in the next video.